In today's lesson, we will discuss vectors and vector addition. What are vectors? In the last two lessons, we talked about physical quantities such as displacement, velocity, acceleration, and so on. And we said each of these quantities, in order to understand each of these quantities, you need to know the direction. Displacement takes place from one position to another position. Velocity specifies the direction of motion of an object. Acceleration has the direction. So there are physical quantities. In addition to having a magnitude, what is the meaning of magnitude of a quantity? Well, if I say that I have two books in my hand, that 2 is the magnitude. Suppose I say the car got displaced 5 kilometers due east. That 5 is the magnitude, due east is the direction. So quantities that can be understood only by describing their magnitudes as well as direction are called vector quantities. What are some of the examples of vector quantities? Well, you know, displacement is a vector quantity, velocity is a vector quantity, acceleration is a vector quantity. Can you think of another physical quantity that is a vector? Suppose I say I applied a force on this object. Now, do you understand what I did with that force? No, you did not. You see, I can use a force to bend a wire, to stretch a wire, to squeeze a wire. Is that right? I can use a force to stretch a spring, to squeeze a spring. Unless I tell you in what direction I applied the force, the description of a force is not complete. Therefore, force is a vector quantity. It has magnitude as well as direction. So in this lesson, we are going to deal with vectors. How do we add more than 2 vectors or more than 1 vectors? When there are 2 vectors or 3 vectors, we will be able to add them to obtain a resultant vector. Alright, all these things we are going to do in this lesson. Okay, let's start. A vector is a physical quantity that has both magnitude and direction. Now, how do we represent a vector when you want to write a paper on it, for example? A vector is represented by drawing an arrow. Its length represents the magnitude and the arrow will represent the direction. For example, the displacement of an object from position A to position B is a vector. Let's draw a vector to represent the displacement of an object from position A to position B. This is an arrow from A to B. The length of the arrow represents the magnitude of the displacement. How much is the displacement? And the direction, how do we represent the direction? Well, if the distance measured from A to B is 2 meters, then the magnitude of the vector is 2 meters. So let's say the length of that vector is 2 meters. The direction of a vector is given by specifying the angle the vector makes with the positive x-axis. So whenever you want to draw a vector, always draw the x-axis, the positive x-axis. Here I have the positive x-axis and the angle measured. Remember, an angle can be positive or negative. the angle measured counterclockwise from the x-axis is a positive angle. If the angle is measured clockwise, it will be a negative angle. Is that right? So the direction of a vector is given by the angle the vector makes with the positive x-axis. There, the angle measured counterclockwise with the positive x-axis, and the angle is theta. Now the displacement vector makes an angle theta with the x-axis. So you can see the description of this displacement vector is now complete. We know its magnitude and we know its direction. Once you know the angle theta, you know the direction of that vector. The displacement vector has a magnitude 2 meter and its direction is specified by that angle theta. Okay, let's now talk about vector components. A very important concept, and pay special attention to it and learn that concept. What is the meaning of vector components? If this is a vector, vector AB, that vector can be constructed by two simple components. Let's talk about that. The displacement from A to B can be achieved by first moving from A to C along the x-axis and then moving from C. Look at this. First I can go from A to C along the x-axis and then move from C to B along the y-axis. You see that? A vertical axis is the y-axis, a horizontal axis is the x-axis. So a displacement from A to B can be achieved by first moving from A to C along the x-axis and then moving from C to B along the y-axis. That means vector AB can be obtained by adding vector AC to vector CB. Now I want you to understand that AC is a vector, CB is another vector. So if you add vector AC to vector CB, the result is vector AB. Now remember, there is a big difference between adding normal numbers or scalar quantities. We said quantities that are not vectors are called scalars. Is that right? We know 3 plus 2 equal to 5. Now, if I add the length of AC to the length of CB, do I get the length of AB? No, I don't. Well, I am not adding the lengths of the vectors, I am adding the vectors. In other words, the result of the vector AC and the vector CB is the vector AB. Adding vector AC to vector CB gives me the resultant vector AB. Or we say here, vector AC and vector CB are the components of vector AB. And look at the vector equation. Vector AB, that arrow on top of AB says AB is a vector. Vector AB can be obtained by adding vector AC to vector CB. Vector AC is along the x-axis and it is called the x component of vector AB. So vector AC is the x component of vector AB. In a similar way, vector CB is along the y-axis and therefore vector CB is called the y component of vector AB. Any given vector can be broken into an x component and a y component. For example, if I have a vector like this, look at that. If I have a vector like that, this is the x-axis. Now, it has this x component and this y component. Look at the way I construct. If this is a vector, then its x component is this and the y component is that. Any vector can be broken into an x component and a y component. All right, let's look at that one more time. In the right triangle ABC, AC is the adjacent side of the angle theta, is that right? And CB is the opposite side of angle theta. And AB is the hypotenuse. Alright, let's now obtain values of AC and CB in terms of AB using a simple trigonometric relation. Now, you know cos theta is adjacent side divided by the hypotenuse. So cos theta is AC divided by AB. And therefore, what is AC equal to? AC is the x component of the vector. And what is AC equal to? AC equal to AB times cos theta. So AC equal to AB multiplied by cos theta. Similarly, sin theta equal to opposite side divided by the hypotenuse. Sin theta equal to CB divided by AB. Therefore, what is CB equal to? CB equal to AB sin theta. The magnitude of the x component is AB cos theta, and the magnitude of the y component is AB sin theta. Now, this is true for all vectors. For example, let me illustrate that with another example. Suppose this is my vector. What are its components? Its components are, that is the x component, and that is the y component. And let's mark the angle. What is the angle made by this? I'm going to call that vector A. Now, this is the name of this vector, vector A. This vector A has this x component and this y component. Now, what is the direction of this vector? The direction of this vector is specified by the angle the vector makes with the x-axis. What is that angle? That angle is this angle, and that is the angle theta. Therefore, what is the x component? Now, the x component is the vector times cos theta. So, this x component will be vector A times cos theta, and the y component will be vector A times sin theta. Now, you must be very clear about it. Whenever you have a vector whose magnitude we know and the direction we know, we can find the x component of that vector. If A is a vector that makes an angle theta with the positive x-axis, its x component will be A